Okay, please subscribe to my channel. And this video, first of all, is on a histogram, how to prepare a histogram. So I'll show you some few things that you need when you're preparing a histogram, and then I'll even share a possible question that you might be asked. Okay, prepare a histogram out of this information. So most of the time in a histogram, we want to take note of certain things, what they call the frequency density. Well, the frequency density is the certain figure that we plot on the y-axis. So imagine you have your graph like that on the bottom. Your y-axis is this side on the vertical line, and then your x-axis is there on your horizontal line. So your frequency density is what you plot on the y, and of course that's why we need this calculation, because it gives you the height of the bar. In short, that's why we need the frequency density. So what is frequency density equal to? So frequency density is actually equal to, your frequency over your class width. Okay, your frequency over your class width. That's what your frequency density is equal to, and you will be doing this for each and every class that you have. Every class I'll be mentioning. Once you find those frequency densities, then you can now plot your histogram, which I will explain soon. So suppose you have a question like that. The frequency table below displays the distribution of ages of passengers on a bus from Kitwe to Lusaka. So you have those, those classes there: 0 to 20, 20 to 40, 40 to 50, 50 to 70, and 70 to 100. So those are your classes that you might be given there in your question. And then suppose the question says prepare a histogram or draw a histogram. So one thing to first take note before you even draw a histogram, point number one: ensure you have class boundaries. What are class boundaries? Well, class boundaries mark common points between classes. So if the first class ends on 20, the next class should equally start where? On 20. Okay, those are the rules you need to take note of. Yeah, so you need to ensure that, okay, while the first class is ending, the second class will equally come and start from that very number, showing that they are first of all maintaining class boundaries. Why is that so important? You might ask. Reason is that a histogram has no gaps. Okay, so where that first bar ends, the other one just like touches itself from there and continues. No spaces, in short. That's a feature of a histogram. That's the reason why we ensure we have class boundaries, which take note that where the last class ended, the other class picks it up from, just like we can see 0 to 20, 20 to 40, just like that. So we have that, right? We have class boundaries. We are set. What is needed now? What we actually now need is we need to prepare the histogram. What do we need? Frequency density. Point number one, we need the frequency density. So that frequency density, we said it's very key because to give us the height of the bar, right? Okay, and then I'll show you how we'll be plotting after we get the frequency density for each class. Which classes do we have? 0 to 20, 20 to 40, 40 to 50, 50 to 70, and 70 to 100. And take note of their frequencies, because if you remember the earlier formula we started with, there was that frequency over class width. Class width is the difference between the highest number in that class and the lowest number, right? Higher and lower limit. So if you look at the first class, the width is 20, right? Okay, which we'll need there, and the frequency there is 4. So let's start and solve those frequency densities for each class. So you prepare your frequency densities, as I said, for each class, right? 0 to 20, as you can see there, it's frequency over class width. The frequency for 0 to 20 was 4, class width is 20, that's why I've done that, 4 over 20. The second class, 20 to 40, 44 over 20, giving you what? 2.2. The other class, 40 to 50, had a frequency of 36, class width of 10, equal to 3.6 as the frequency density. 50 to 70, that class, it had 28 frequency, then the class width was 20. Then you divide 1.4 as the frequency density. Finally, 70 to 100, frequency was 6, class width was 30, frequency density 0.5. So it's now at this point now that we try to now plot our histogram, right? Yeah, so you have your frequency density, which we said will be on your what? On your y-axis. Take note, please. The frequency, we said that it will be on your y-axis. So we want to now plot our histogram, by the way. Okay, so sorry for that. It's actually for the last class 70 to 100, it's 0.2 actually as a frequency density. So now we need to plot the histogram. So your histogram, okay, will have that kind of shape. First of all, here we'll just we'll just know, okay, that there is frequency density there, FD, and of course the bars will be along this line, if anything. So what we'll be doing is this. The first class was 0, right? So we can put 0 there, 0.0, and it's ending on a certain point, 20. So we can just say, you just put reasonable distances. Okay, then you plot. You make a scale. So first of all, 0.2, 0.4, 0.6. Okay, something like that. 0.8, 1, 1.2. And you have to go up until 1.4. So for the sake of my space, I'll just estimate that, okay, 1.4 can be here because we had a certain frequency density that reached 1.4. Okay, so we are now plotting. The first class was from 0 to 20. So our bar will run from 0 to 20. And what was the density? Frequency density, sorry. So we had the first one was supposed to be 0.5 actually. That's the first frequency. So 0.5 is in between there. That's your first plotting there of your histogram. The next class was 20 to 40. What was the frequency density? 20 to 40. We tried to plot that one as well. Okay, just a minute. You notice that, okay, I've done some change to my histogram, which I started with. I've just realized there's actually a frequency density of about 3.6, which I missed. Yeah, if you rewind, actually, that's why I've just readjusted those, my scale this side. Okay, don't mind my scale. It's just for the sake of the screen that I have right now. But you need to make constant progression, like 0.2, 0.4, 0.6, 0.8, 1, 1.2, that kind of scenario. But okay, these things will have to be on your y-axis. That's the concept you need to get. So we're plotting the next class, 20 to 40. What was its frequency density? 2.2. So you would take where this one ended and go further with your line and draw your bar there. That's all. That's for 20 to 40. That was the next group. Next group is 40 to 50, which had a frequency density of 3.6. You also take up from where the friend ended. Okay, you found 3.6 on that high place, and then that's all. I said the frequency density just gets to give you the height of the bar. Please take note of that. Yeah. The next group is 50 to 70. 50 to 70 had what was the frequency density there? Let's just try to rewind. If you rewind there again, you would find that it's actually 1.4 as the frequency density. So they're attached. Make sure they're attached. The bars do not leave gaps. That's 50 to 70. Finally, there is 70 to 100. That particular bar has a height of 0.2 according to the frequency density we found. And that's how you draw your histogram basically. Okay, they just say that the area, this area in this bar is depicted by the frequency. Yeah, according to how it is by theory, if anything, on a histogram, that the area of a bar is depicted by its frequency. That's just something to take note. But these are the tips on how you draw a histogram, by the way. Okay, just ensure that your frequency density is always there, and one common property: no gaps between the bars.